Ever wondered how your home appliances work? It all boils down to some basic electrical terms. Welcome to the fascinating world of electrical engineering, the science that unravels the mystery behind the functioning of your everyday devices. From the buzzing alarm clock that wakes you up to the comforting warmth of your electric blanket, electrical engineering plays a crucial role. We're going to decode some of the key terms that form the backbone of this field. We'll start by exploring voltage, the driving force that pushes electric current through a circuit. Then, we'll move on to current itself, which is the flow of electric charge. Power and energy, the dynamic duo that defines the capacity of your devices, are also on our list. Finally, we'll delve into the world of capacitors and inductors, elements that store and release energy in unique ways. Ready to dive deeper? Let's first understand voltage. Voltage, in simple terms, is the force or pressure that pushes the electric current. Imagine a river. The steeper the slope, the quicker the water flows. Similarly, voltage is like that steepness driving the current through an electric circuit. But just as the steepness varies from one river to another, voltage varies across different devices. Your mobile phone operates at a lower voltage than, say, your refrigerator. So, voltage is essentially the electric force that propels the current. Now that we have an understanding of voltage, let's move on to current. Current is the flow of electrons. Think of it as a river of charge flowing through a wire. This flow of charge is what powers our devices, from the smallest smartphone to the largest industrial machinery. Current is measured in amperes, often shortened to amps, and is determined by the amount of charge passing a point in a second. It's a fundamental concept in electrical engineering, underpinning everything we do with electricity. With voltage and current covered, it's time to discuss power. Power is the rate at which work is done or energy is transferred. In the realm of electricity, power represents how quickly an electrical system can do work. It's a simple multiplication of voltage, the force that pushes the charge, and current, the flow of charge. Picture it as water flowing through a pipe. The greater the water pressure, voltage, and the wider the pipe, current, the more power or work can be done. Next up, we'll be discussing energy. Energy is the capacity to do work. In electrical terms, it's the work done by an electric current. Imagine a flowing river powering a water mill. The current is like the river, and the mill is a device that turns that flow into useful work or energy. Now, power is the rate at which this energy is used or produced. It's like the speed of the river's flow. It's not just about having energy, but how quickly you can harness and use it. Now, let's move on to some interesting components: capacitors and inductors. Capacitors and inductors are essential components in most electrical devices. Now, let's delve a bit deeper to understand what these components are and why they are so important. Let's start with capacitors. Picture a capacitor as a tiny, rechargeable battery within an electrical circuit. It stores energy in an electric field, waiting for the right moment to release it. The amount of energy it can hold depends on its capacitance, measured in farads. When a voltage is applied across a capacitor, it charges up, accumulating energy. And when the voltage drops, the capacitor discharges, releasing that stored energy back into the circuit. Now moving on to inductors. If capacitors are like batteries, think of inductors as traffic cops for electric current. They are a bit more complex than capacitors. Inductors store energy in a magnetic field, and their ability to do so is measured in henries. When the current flowing through an inductor changes, the magnetic field changes as well. This change in the magnetic field induces a voltage that opposes the change in current, helping to smooth out abrupt changes and keep everything running smoothly. In essence, capacitors and inductors are the guardians of energy and current flow in an electrical circuit. They store energy when there's plenty to go around and release it when it's needed, and they keep the flow of current steady and controlled. These were some of the basic terms that form the foundation of electrical engineering. So we've covered some fundamental concepts in electrical engineering. We've learned about voltage, the electrical force that drives current through a circuit. We explored current, the flow of electric charge. We delved into power, the rate at which energy is used or produced. We discussed energy, the capacity to do work. And we examined capacitors and inductors, components that store energy in an electrical circuit. And that's a wrap on the basics of electrical engineering. Stay curious and keep exploring.